Class 7. I'm Mrs. Campbell, and today we're going to be talking about theoretical probability. Let's jump in. Theoretical probability is a ratio expressing the ways to be successful to the total possible outcomes. And we've talked about this concept before. The set of all possible outcomes, that is called the sample space. And this is a new term you might want to write down. So for example, the sample space for tossing a coin is heads and tails. Theoretical probability, it does not use an experiment. It uses mathematics to state what should happen. It's kind of like probability on paper. And a way to find theoretical probability is by using the following equation. You might want to write this one down as well. The probability of success equals the number of ways to get success over the total number of possible outcomes. So one fair die has an equal probability of landing on any number using theoretical probability. A die is a six-sided figure with dots representing the numbers 1 through 6. So the sample space is all the possible outcomes, which is basically meaning what numbers could possibly be rolled. And so the sample space would be 1, 2, 3, 4, 5, and 6. Sample space is 6, and the total number of possible outcomes is 6. So each number is on one and only one side of the die. And there's only one way that you can roll a 1, 2, 3, 4, 5, or a 6. So that means that each number has an equal chance of occurring. So therefore, there's an equal chance of each number being rolled. So here are the theoretical probabilities of rolling each number. Now remember, theoretical is on paper probability, and we didn't actually roll the die. So the probability of it being a 1 is 1 out of 6. The probability of it being a 2 is out of 6. In fact, for every number 1 through 6, the probability is 1 out of 6. You're seeing a pattern there? So it also proves, as we've discussed in a video in the past, that the sum of all theoretical probabilities of a sample space is going to be 1. Because if we added 1, 6 plus 1, 6 plus 1, 6 all 6 times, then we get 6 over 6, which is a total of 1. This is all theoretical probability. So what if we were to compare it with an actual experiment of rolling a die? This is pretty interesting, actually. Let's look at these two graphs. The first one shows the theoretical probability of rolling a 1, 2, 3, 4, 5, or 6. And as you can see, all the probabilities are equal because it's on paper. It's not actual. The second graph shows an experiment of rolling a die 600 times and recording the results. The dotted line shows where all probabilities would be if they were equal. The probabilities in these graphs are using the decimal form, and a probability of 1 over 6, that's equal to 0.166666. So what do you notice? Well, the experimental graph shows that with 600 trials, the probabilities of rolling each of the numbers is approaching theoretical probability. However, as we stated in an earlier concept, experimental probability is real-life probability. And we can expect, with even more trials, that we would come even closer to theoretical probability. So looking at the two graphs, we can definitely say that the experimental probability shows that with more trials, the more times we roll the die, the probability, with more trials, the probabilities are more likely to get closer to theoretical probability. Let's look at another example. A card is drawn at random from a standard deck of cards. The sample space of possible outcomes is shown in the image. So, and you'll see it on the next page. What is the theoretical probability that it will be a club? What is the theoretical probability that it'll be a 3? And what is the theoretical probability that it will not be a king? So this is an example of a question that you might get related to probability. So let's look at number 1. What's the theoretical probability that it will be a club? First, we need to find the total sample space. That's going to give us the total number of outcomes. So we know that there's 13 hearts, 13 spades, 13 clubs, and 13 spades, clubs, and diamonds. So we have 13 plus 13 plus 13 plus 13. That equals 52. The total sample space is 52. So there are 13 cards that are clubs, and that is our number of successes. So the probability of it being a club is 13 over 52. Once we simplify, 1/4. That's not so hard. Okay, what is the probability? The second question is that it will be a 3. Well, the total sample space is 52. There are 4 cards, we know, that are 3s. So 4 is our number of successes. We just put that over 52, simplify, and we get 1 over 13. And then third was, what is the probability of getting a king? We know that there are 4 kings. So the probability of pulling a king is 4 over 52, reduced, that is 1 over 13. So the total probabilities must add up to 1. We've talked about this before. So if the probability of getting a king is 1/13, to find the probability of not finding a king, because we're not totally done with that question yet, we basically just subtract the probability of getting a king from 1, the total of all probabilities. So we have 1 minus 1 over 13 equals 12 over 13. So the theoretical probability of not getting a king is 12 over 13. All right, guys, that does it for this lesson. Thanks for joining us. We'll see you next time. Bye-bye.